Part A of FRQ1 asks to draw the free body diagram of the block and label all the forces acting on the block. So for the block, we have the incline, the angle, the block. We have normal force, Fn, which is acting up. And then we have F of G. We have the applied force, F, as well as Fk, which acts against the block. And then part B asks us to derive an expression for the contact force exerted on the block by the incline in terms of the given variables. For that, we have the net force, which equals the mass times acceleration. For the contact force between the block and the incline, we can do F of N minus F of Gy, which is down, minus the applied force in the down direction, would be Fy, which equals 0. F of N minus mg cosine theta would be Fgy minus F sine theta, which would be Fy minus equals 0, which would get us Fn equal to mg cosine theta plus F sine theta, which would be part B. And then part C asks to develop an expression for the block's acceleration up the plane in terms of the variables. And then for part C, we would again do net force equals mass times acceleration. We would do it F of x minus F of G of x minus F of friction. F of x would be the applied force moving the block. F of Gx and F of friction would be acting against it, which would equal mass times acceleration. F of x is equal to F cosine theta minus mg sine theta minus mu of mg sine theta plus F sine theta, which would equal mass times acceleration. And then A would just equal F cosine theta minus mg sine theta minus mu mg sine theta plus F sine theta all over that would be our expression for A. And then for part D, it says to develop an expression for the magnitude of the force F that will allow the block to slide up the plane with constant velocity. What relationship must theta and mu satisfy in order for the solution to be physically meaningful? For this, we would again do the net force equals mass times acceleration. We would do F of x, the applied force, minus Fg of x, force of gravity in the x direction, minus the force of friction, would equal 0. F of x is F cosine theta minus mg sine theta minus mu mg cosine theta plus F sine theta equals 0. And then we can distribute out mu, and then at the same time I'm going to switch them for their sides. Mu F sine theta, it's mu times F sine theta, which would equal mg sine theta plus mu mg cosine theta. Just moving it to the other side and distributing out the mu. And then we can factor, so F cosine theta minus mu sine theta equals mg of sine theta plus mu of cosine theta. So our F would now equal mg of sine theta plus mu of cosine theta over the cosine theta minus mu of sine theta. And then for this problem, we have the cosine theta minus mu sine theta, which could be turned into cotangent theta minus mu. And for this, we need our cotangent value to be bigger than the value of mu, so that we have a positive, bigger value of F, which means that the friction would be small enough for the force to push the block up the ramp, and so that the block would be in motion instead of friction being too big and keeping the block out of motion. So that would be for part D. And then part E would be if m equals 2 kilograms, theta equals 20, mu equals 0.33, calculate the force F required to accelerate the block up the ramp at a constant rate of 0.5 meters per second squared. And then for that, we already have our formula. This one we would solve by doing the net force. The net force is equal to mass times acceleration.